In this video, we're going to talk about measures of univariate data. Univariate just means one variable. First of all, let's talk about the two types of data that we can collect, quantitative and qualitative. So again, at any time that you need to pause the video, please pause to write these definitions in your notebook. So if we were going to describe this ice cream cone and we're going to describe it using quantitative data, that means we're going to have to use data values that are numbers. For instance, we could say that this ice cream is about, we can just take a guess, maybe 4 inches tall. So we could say that it is 4 inches. That's quantitative. We could say that it cost $3 to purchase. We could talk about the volume and give approximate volume. So anything that deals with data values that are numbers is quantitative data. If we want to talk about the qualitative data and describe it using names or labels, we could describe it as being green. Maybe it's a lime flavor. So this is qualitative data. It describes it with names or labels. Now, there's something you need to be aware of. Sometimes number values act as names, and so therefore they are qualitative. So such things as a telephone number, that is qualitative even though it deals with numbers. We could say a zip code, a locker combination. So just be aware that just because you see a number doesn't automatically mean it's quantitative, but most of the time it does. So for this unit, the first 3 lessons, we will be dealing with quantitative data, which are number values. And now we're going to break our unit into 2 categories. So we have qualitative, quantitative, but then we also are going to have univariate data, which is one variable, and we'll have bivariate. So the first 2 lessons that we're going to talk about, 7.1 and 7.2, is univariate data. It is quantitative data, so we're talking about numbers, where only one variable is involved. And the purpose of this measurable data, so we can measure it, that's what makes it quantitative, we can measure it, is to describe the data. It is not to determine causes or relationships. So this dot plot represents the number of hours of study that different individuals have when they're studying for some test. So this is univariate data. It's just dealing with hours of study, nothing else. This scatter plot is not univariate data. It represents bivariate data, which we'll get into at the end of this unit. And you can see it involves 2 variables, how many hours you spend studying and the score that you get on your final exam. So there's a relationship going on here. But univariate is not dealing with causes or relationships. Within this lesson, we're going to break this single lesson into 2 parts. We're going to talk about the measures of central tendency first, and then part 2, we'll talk about measures of variation. So there are 2 ways that you can measure univariate data. You can talk about the centers and the spread. So there's a lot of interchangeable words that we can use and you'll hear throughout this unit. So let's talk about the centers of measure first. That is going to be part 1. Now you are probably familiar with these. So the measures of central tendency is a single value that helps describe a whole set of data points. So for example, when you get your report card or your progress report, you don't have all your math grades there. You have a single number that represents all of your math grades. And that number is the mean. On your report card, we use the mean, which is the average. There's also the median, which is your middle number when you line them up from least to greatest, the middle number. And then you have a third central tendency, and that's the mode. It's the number that comes up the most often. So again, this is probably a review from the past couple of years. Now, again, pause the video if you need to write all this down. In the quick check quiz that you'll have, every question is coming straight from these notes. So let's talk about which center is best to use. So we have the mean, the median, and the mode. Here is the symbol. X bar is the symbol for the mean. So when you see this in statistics or on a calculator, you know that just means the average. So the mean is, you're going to use the mean when there's no outlier. So please make sure you put that in your notes. It is most popular in business, and it yields one distinct answer. Then you have your median. You're going to use the median if there is an outlier. And in this course, you will learn that there is actually a formula that tells you if a number is an outlier or not. The median is not as popular as the mean. However, for our course, if there's an outlier, we're going to say that we're going to use the median number to represent. The mode. It is just used to describe the most popular value of the set. It is the least reliable indicator of centers. So again, please write this in your notes. Let's talk a little bit about outliers. Again, this is not new to you, but there may be some new ideas. So it's just a value that lies well outside the range of the other data values. It can either be at the lower end or at the upper end. Now, let's write this in your notes. A resistant measure. This just means that a resistant measure is a measure that is not affected by an outlier. So when we're talking about centers for the part 1, the median is a resistant measure. It is not affected by an outlier. So anytime that there's an outlier, we're going to use the median number instead of the mean. Now, when we get into measures of variability or measures of spread, how spread apart the numbers are, IQR is a resistant measure. But again, we'll hold off for part 2, but you can go ahead and write that in your notes. So the resistant measures, the measures that you're going to use if there's an outlier, you're going to use the median when we're talking about the center, and you're going to use the IQR when we're talking about the spread of the data. Okay, here are the outlier formulas. So here, the lower fence. This is if you have a number that lies to the left of the data, we're going to call this the lower fence. So again, please write this formula down. So you would put in a possible low number, then it's less than, and then you're going to have quartile 1 subtracted times 1.5 times the IQR. And again, we'll refresh all of these concepts as we get through this lesson. So again, if you'll just write this in your notes. Now the upper fence is pretty much the exact opposite. You put in the larger number that could possibly be an outlier, and instead of Q1, we're going to look at Q3. And instead of subtract, we're going to do plus, but we still have the 1.5 times your IQR. So in the lower fence, it's less than, upper fence, it's greater than. Here we have Q1, here we have Q3, this is subtract, and this is add. And then this part is the same in both. Once you plug all these values in and you do your order of operations, if your statement is true, that number that you plugged in for here is indeed an outlier. Same for here. If you get a true statement, it's an outlier. If you get a false statement, that number is not an outlier. Okay, throughout this lesson, we're going to use these two data sets to help explain the centers and the spread of measures of univariate data. So we're going to take a look at Jude's science grades and his math grades. We're going to analyze and get all the statistical values, and we're going to see which does he do better in, and also which class does he have more predictable grades. Now, I'm not going to play this video, but you can open it up and from the PowerPoint inside your pathway, and you can play the video of how you calculate the mean in your calculator. So I'm going to show you step by step how to do this. So you're first going to get your TI-30SX, and you can clear it by clicking second, 0, and then 2, and that will clear its memory. Then you're going to click data, right here, the data button, and you're going to enter all your statistical data points. So all of Jude's science grades are going to be first. As you enter them in, after you enter the number, you click enter each time. And so as you can see, all his grades are in this L1. That stands for list 1. Next, once you get all the grades in, then you're going to click second and stat. It's the data button, but we're looking at second stat. When you click second stat, it's going to ask you, are you trying to calculate one variable statistics or two variable statistics? We're going to do one, so you click enter because it's going to default to the first choice. Then when you get to this window, everything is already highlighted that it should be. You're going to use list 1. Our frequency is going to be 1 for this course. So you just click enter, enter, and then it'll go and calculate. You click enter, and then once you do that, you're going to have a whole list of statistics, which we will be using again in part 2. But for now, we're just looking for the mean. And we can also go ahead and get the median. So you can see here without having to scroll down, if you needed to scroll down, what you do for the median, okay, you're going to use this up and down arrow buttons. So this X bar tells us that our mean, our average is 85.2727, keeps repeating. So let's just round to the nearest whole number for the mean. So our mean is at 85. Now, if you kept scrolling down, you would see where it says QT for quartile 2, which is also the median, and you could identify the median. Okay, so when we did that in our calculator, we got a mean of 85. And then in our median, if we scroll down, we would see that the median, or the Q2, was an 88. Now, just looking up here, we can kind of glance through and see which number shows up the most often, and I believe it's 82 here. So these are the 3 numbers that can represent Jude's science grade. So this one single number, whether it's the 85, 88, or 82, this single number can represent all 11 of these grades. Now again, since we're not sure if we have an outlier or not, we're going to go with the mean. And on a report card, they do use the mean. But if we do find out that this 52 is a possible outlier, if it is, we would choose to use the median, because you could see this 52 probably caused his grades to be skewed a little to the left. It probably dropped his grade average a little bit. So sometimes when you don't make a great grade, like you bomb something, maybe you wish the county would use the median instead of the average to give you your grade report. Okay, now we're going to do it again. And so again, you can just pause the video and you're going to input these. I would clear my calculator. And again, that's just second 0, 2, and it clears the memory. And then you're going to go to data and you're going to enter these grades into list 1. And then you're going to go to second stat, and then you can see the average. So the average for his math is a 90. He has a 92 average, and he has a median of 93. And then the grade that showed up the most often is a 95. So it doesn't really look like there's any outliers here, so we would definitely use the mean. But if there was an outlier, we would go with a median. But you can see a 92, 93, 95. Really, all those numbers are pretty close to represent his math scores. So now let's compare his science grades to his math grades. So you can see that in science, if there was no outlier, we could compare the means. So the 85 and the 92. You can see that he does a little bit better in math and science, but there probably was the outlier. That 52 was probably an outlier, so we would use the median, because that 52 would have skewed the mean, and you can see how it brought it down somewhat. So let's take a look at a summary. So summary so far, this is what you need to know. We're just talking about the measures of center of univariate data, the mean, median, and mode. You need to know that you're going to use the mean when there's no outlier. You're going to use the median if there is an outlier because it's a resistant measure. And then the mode is the least reliable data point. So that is used the least.